Hey guys, hey gals, how you doing? Thank you for hitting the play button. Welcome, welcome, welcome. Thank you for stopping by, joining to learn. To think about that a little bit, but yeah, you're here to learn. Let's go. Turn that up. I love it. You know I love that. That's awesome. Support you in your endeavors, in your journey towards learning. 100% support you. I'm gonna leave it at that. But yeah, that is so awesome. So awesome. Let's go. I love it. We're gonna continue, guys. We're just gonna stay focused, stay on track, and let's continue. Last we were talking about, I guess I should quickly make sure. I'm sure everything's good on the stream, but sometimes I kind of fail as a mod. Just want to make sure we're okay. Let's continue. Yes, good. Just want to make sure you can hear me. That's awesome. All right. Let's continue learning. This is to support you parents that are probably homeschooling your child, which is awesome. Support you on that, your decision to do that. So yeah, gonna try, I'm gonna do my best to do a bunch of videos for you parents that need some maybe additional support or whatever for your child. If you have any questions, concerns, or any specific area in mathematics that you would like me to do a video on, just let me know. I'm not trying to brag or anything. Lucky for me, when I went to college, I had instructors that taught the actual course, what I was supposed to learn, and nothing else and nothing more. So I am grateful and thankful for that. When I was in college, it's a technical school, right? So basically a technical / blue collar guy. I've worked in office environments, and I've worked in the field. So not to go down my resume, but mathematics was just one of the things that clicked for me. I love physics, I love science, and I love mathematics. And let's just say I pretty much majored in calculus. So it's been a number of years, probably a little bit rusty in my calculus skills and doing derivatives and integrals and such, which is fine. But bottom line, I really enjoy mathematics, and I hope if I could help you, if you're watching, your student or parents or whichever, helping your child learn and grow. Hopefully, I could do that for you. So this is great. Let's go. So that's kind of just a little bit of about me. Name is Johnny. Yeah, let's just go. So we're basically working on this section we're going to begin with in mathematics. It's I know you guys have different names and terminology for levels of school, like middle school and whatever. We call it high school. I don't know if it's the same where you guys are. This is grade 10 level mathematics. I guess you could kind of fit it in with grade 9 or whatever. A lot of it's just basic life stuff. So this section is basically mass, capacity, and temperature. All right, guys? So we're kind of going over the definitions. I mean, you have to have an understanding. So let's have an understanding. Now I'll just bring this up. I've got some scans that I kind of put together. Now I know it's not full screen. I wish I could get it full screen for you guys. You literally, if you're on computer, you could do what's called a snipping tool. it's great. So if I do a snipping tool, click new, you can actually just kind of shape what size you want, and to the page, dimensions, and save it. Essentially, you would save it, right? And then at that point, you can print it off. So that's pretty easy peasy lemon squeezy. Hopefully that'll help. I mean, it's kind of like a fill in the blank sort of thing, right? But we're going to just go over the definitions without really filling it out, okay? Now, we were last working on mass and weight. We're going to continue. We're going to finish off with weight, and then we're going to continue with what is capacity. All right, guys, let's go. So in mathematics, capacity refers to the amount. Actually, I was going to finish with weight. My bad. Sorry, guys. Clicking the right link here, or tab link. Okay, let's do this again. Still working in mathematics. Weight typically refers to the force of gravity acting on an object, or how heavy an object is. Okay, it's a measure of the gravitational force exerted on a body, and it's directly proportional to the object's mass. Now, so you guys understand what directly proportional means. Actually, you know, we have these values, but I'm just gonna go, I think I go Control Z. I'm just gonna undo all this. This is good enough. So directly proportional means this, guys. So I'm gonna go force. We're talking about force, right? Equals force or weight. It's, you know, it's kind of the same thing. Equals mass. I like to use dot for multiplication. Okay, so that's what it means. Gravity. Okay, so that means directly proportional. Inversely means this. If let's say I needed to solve for mass, so m, it doesn't really matter which side of the equation sign you have this, because it's the same on whether m is on this side or on this side, it's still the same. Okay, so when we're so imagine all of this stuff is like this. It's all over 1. Okay, so if you think of it this way, these are all numerators and you imaginary 1, right? I'll use imaginary 1 a lot so you guys can visually understand. Okay, so I'm just going to undo that. So essentially there's still fractions, you just don't have it, right? So we're going to solve for mass. To solve for mass, we essentially just, it's kind of like multiplying by g for both sides, or I mean dividing. We would divide by g on both sides. So if g was here, we would essentially cancel g on this side, and we would be left with g on this side. So we're going to take g and pretty much just go divide. So I'm going to go like this. F is still the numerator. Okay, I know I should go over fractions a little bit, but here we go. So that's how you do that. So that's how you would solve mass. Bear with me if I mess up my talking. I'll try to catch myself. Okay. So that's how that's done. So this means force is directly proportional to mass times gravity, whereas gravity is inversely proportional. Force is still directly proportional because it's the numerator part, but gravity is inversely proportional. So if you hear those terms, that's what it means. Basically, it's multiply and divide, essentially. Okay, so let's continue. I just wanted to quickly explain that. All right, so okay, there. So to finish, it's a measure of the gravitational force exerted on a body, and it's directly proportional to the object's mass, just like we're showing right here. Okay, I'm going to try my best to do straight lines. It's not bad considering. Okay, directly proportional. So key points about weight in mathematics. Definition. Weight is the measure of the force of gravity acting on a body. Remember, body has mass. That's unchangeable. It's a constant, essentially. I mean, I guess your mass changes as you grow, right? But your mass is still your mass. Okay, it's your molecular structure, if you will. Relationship to mass. Weight is calculated by multiplying an object's mass by the acceleration due to gravity, often expressed as W equals mg, right? Or same thing. You can use these subscripts. This is what's called a subscript. Supposed to show a W there. I'm going to just erase it and fix it. I could actually increase the size of my eraser. It's the nice thing about Krita, not Greta. I'll get my English out today. There we go. Okay, that's a bit better. Okay, force, weight, it's all the same. Okay, so let's continue. Units. When weight is measured in newtons, which is N, right? Newtons. So the units would be N, right? For newtons. Okay, in everyday usage, it's often measured in the same units as mass, right? So when you have mass, which is, obviously it's could be in kilograms or pounds, right? And gravity is, or acceleration, either way, they're both the same. The units for acceleration or gravity is meters per second squared. Okay, so when you multiply kilograms times meters per second squared, you essentially get a Newton. Okay, that's supposed to be a cloud. Draw better clouds on paper with a pencil, guys. Let's go. Excuse me. All right, where are we now? So it's often measured in the same units as mass, like kilograms or grams, though it's understood to be the force of gravity on that mass, right? In mathematics, weight can also be used in the context of weighted averages or weighted functions, where different data points or values, I'm kind of going on a little bit extra here, are assigned a different importance or weight. We'll just kind of ignore all that stuff. In summary, weight in a mathematical context primarily refers to the gravitational force acting on a body and is a measure of its heaviness, right? It's a measure of its heaviness. This value right here. Okay. It is calculated by multiplying mass and the acceleration due to gravity and is commonly measured in newtons, right? Again, kilograms times meters per second squared. Essentially, it'd be like this. I'll try to draw it here. So essentially times meters and everything. This is all the numerator. Okay. And essentially that is this. Okay, guys? All of that. Isn't it a lot easier to say Newton, right? Let's go. So answer. Okay, so this is generative AI. Essentially, I searched definition of weight and mass. I have been kind of not really on the bandwagon in regards to AI, but I think when you do Google search or Bing search, I think the AI overall gives you a pretty good result or for information to read. Okay, So a little bit on the bandwagon in regards to AI. I'm a bit of I like coding. If you guys know who I am and watch my channel, um, I guess yeah, it's just all part of it. All right, let's carry on. The weight of an object refers to as the force of gravity that is acting on the object. Furthermore, its calculation is mass times k. We've already kind of been through that, so that covers that. So let's carry on. Let's work on. Let's get this. We're gonna work on capacity now. What is capacity? Now I kind of have. So just to give you an idea, what is capacity? What is it really? Well, when you fill your glass in the morning, whether it's coffee or milk or juice, a cup has capacity, right? So that's kind of gives you an idea of what we're leading into here, okay? So in mathematics, capacity refers to the amount of fluid a container can hold, right? So which is the same as volume, right? Essentially, if you calculate the area, the internal area, volume, the internal volume of that cup, you can figure out its capacity based on its volume, right? We'll try to do some examples too here, guys, so stay tuned. All right. Okay, which is the same as volume in the context of measuring liquid. It is measured in units like milliliters. Again, guys, I grew up with imperial first, so understanding the imperial system, I have no problems. Okay, that was the first system I learned. The metric system kind of came when I was in, obviously, elementary and middle school. Okay. All right, so it is measured in units like milliliters and liters in the metric system, or pints and gallons in the customary system, which I call the imperial system. Okay, here's a more detailed explanation. Capacity is the maximum amount of fluid a container can hold before it overflows. Okay, its relationship to volume. In mathematics, capacity and volume are essentially interchangeable terms, both referring to the amount of three-dimensional space a container can hold. Okay. All right, units of measurement. Commonly, units for measuring capacity include, like for the metric system, milliliters, liters, centiliters, which isn't common. The most common is milliliters and liters, guys. And the imperial system, fluid ounces, cups. I'm used to cups, saying cups a lot. Not so much gallons. We use liters and cups a lot. We kind of interchange both of both systems over here in the north. Pints, quarts, gallons, of course. We'll get into some examples so that you can organize it in your mind, what a liter is and what a gallon is, right? How many liters in a gallon, for example? We'll get there. Okay, here's a couple examples though. The capacity of a bottle might be 1 liter, right? The capacity of a bucket might be 20 liters. That's quite a bit, actually. Capacity is the maximum amount that something can contain. Volume is the amount of space that a substance or object occupies. The two terms are interchangeable and can refer to the same calculation or measurement. Right? So volume would be the empty space, and obviously the capacity would be the filled space. You can look at it that way, I guess. There we go. The actual capacity is the volume of liquid that can be held in the container when it is full. The apparent capacity of a glass vessel is the total volume of liquid that the vessel can hold. The actual capacity of a vessel is the volume of liquid that the vessel can hold if the liquid is at its maximum level. Okay, vessel, essentially, you can just think of it as an item, a cup. It's just another word you can use to describe something. Right? Our body, people a lot of times will call our body a vessel, right? Okay. So now let's talk about volume. Let's do the definition of volume first. And then we'll lead into that, okay? Okay. So, I guess I should have went. Hold up. Let me just click back here. We'll see if we can find something a little bit better in mathematics, right? Just so we stay on topic. Okay, in mathematics, volume refers to the amount of three-dimensional space occupied by a solid. Okay, we kind of already said that, but repetition is good. It's essentially the space inside a 3D object, often measured in cubic units like cubic centimeters or cubic meters. I like the simple, working with just common like inches, common millimeters. When we get into the third dimension, converting third dimension units, I'm not a fan of, but we'll try to do some examples. I prefer to stick to the just one-dimensional units, if you will. Okay, key aspects of a volume. Of course, you guys, we can all calculate volume if we wanted to. That isn't the problem. It's just converting cubic centimeters to cubic liters. That's kind of what I'm referring to. Not a fan of that. All right, so volume is a three-dimensional concept, meaning it measures space along three axes. In other words, we typically use X, Y, and Z for us that are, use that a lot. That's the three dimensions to us. Another way to look at it is length, width, and height, right? Cubic units. Volume is typically measured in cubic units, reflecting the three dimensions involved. Okay? I'm just going to try to keep, change up I know you guys are just listening. Hopefully, these kind of videos, once I start getting into writing more and doing examples on Krita, it'll get more interesting. If you're watching this kind of video where I'm just kind of going over definitions, I mean, by all means, just chill, relax, put the headset on, and just listen. It's no different than listening to audio book, okay? All right, let's continue. I hope you're having an awesome day, evening, or night, wherever you are. Okay, relationship to area. Well, obviously area is two dimensions, right? So where area measures the space within a two-dimensional shape, like a rectangle. So it's like one plane, plane, right? Like it's a singular plane, right? To create a 3D object, well, obviously you need more than one plane, right? Okay. Okay, so volume measures the space within a three-dimensional object, like a box, right? A box would be a three-dimensional shape. Different shapes have different formulas for calculating their volume. For example, the volume of a rectangular prism is length times width times height. Okay? Don't really calculate prisms very much. Good job. All right, so here's some examples of fish tank. So you can literally calculate the volume of liquid within. Of course, you're not going to fill it to 100% capacity, right? So the volume of a fish tank is the amount of water it can hold, right? Depends on the the dimensions of the tank itself, right? The tank, you can look at it by sorry guys, probably getting a little tired, but you can look at a fish tank kind of like a box, but think of it as a stretched out box. It's a stretched limo fish tank. Hilarious. Okay, so room. The volume of a room is the space it occupies in 3 dimensions. Cylinder. The volume of a cylinder is calculated using the formula pi r squared h, where r is the radius. Radius, guys, is half the diameter, okay? It's 2 radius equals diameter, okay? And radius of the base, and its h is the height, okay? In math, volume, we'll do some examples, okay? We're just kind of talking about it. Get your brain, listening to the words. Volume is the amount of space in a certain 3D object. For instance, a fish tank has 3 feet in length, 1 foot in width, not a fan of saying that word, and 2 feet in height. To find the volume, you multiply the length times the width times the height. It's really straightforward. They're essentially, guys, they're all directly proportional to each other. Volume is directly proportional to length times width times height, which is 3 times 1 times 2, which equals 6. So here's my last bit of advice. Remember your units, guys. Remember your units. Okay? So each measurement is a foot, right? So essentially we multiplied foot times foot times foot. Okay? Which gives us foot cubed or feet cubed. I know I said that wrong. We all know it's feet cubed, but I'm just trying to help you understand it. Okay? So don't forget your units. So the answer is 6 feet cubed. All right. What is next? Bear with me. I need some coffee, guys. Usually I make some noise whenever I drink coffee. Oh, yeah. Okay. So now we're on, let's see, what else do we have? I have some examples. We could talk about measuring units and such. So here we go. I'll just give you some visuals, and I guess I could use this as reference, right? It's just a site I found. I was searching for, volume or whatever, and this is one of the sites that came up. You could use it, check it out if you want. It's up to you. So of course you got units and distance, right? Okay. You use a ruler to measure inches, or you can measure yards. Use, measuring cups to measure, volumes when you're baking or cooking. Same thing with a tablespoon. A pint would, for us here, that looks like a half a liter. Is that right? No, 250, a quarter of a liter. 250 milliliters, which is a quarter of a liter. This looks like a full liter. And a gallon, essentially it would take, I believe, 4 of these to make a gallon. It's pretty close. Okay, 4 quarts is a gallon. I believe that's right, guys? we're kind of odd over here, guys. Like I said, I grew up with the imperial system, so I kind of use both. But when we're talking about milk and such, I don't know. We use the metric system. It's really strange, but that's kind of what we're accustomed to. And of course, weigh scale for measuring weight, like an ounce or a gram or whatever, right? Okay, so I'll bring this back. We'll go over a couple of other examples here. I guess I could give you some visual examples. Won't hurt. Something visual would be nice for you guys instead of staring at a blank screen. Okay, I'm using this as an example website. They have no idea, but I guess I should probably give them credit. I'll make sure I have like some sort of link or something for you guys, okay? If you would like. It's a recommendation. It's not something you have to do, but it's good reference information if you like. All right, length describes how long a thing is from one end to the other. Length is used to identify the size of the object or a distance from one point to another. Let me just check my stream here. I'm trying to keep these short for you guys. Okay, we're already kind of half an hour. I don't know how long I should have these. I think we're going to kind of stop there. We'll go into measurement. This is kind of going a little bit longer than I wanted it to. Let me know, guys, what is kind of a long enough video time frame. Half an hour, 45 minutes? That kind of the magic number? I don't know. I'm trying to think of your guys' lives, right? Again, if you have lots of time, you can watch them in a series. We're gonna leave it at that, and then we'll continue with this in the next stream. So appreciate you being here. Johnny with Whiskey Tango Sharp. Parents, children's. I don't know what else to say, but appreciate you learning here and watching. You guys are awesome. Hopefully I can help you guys. That's kind of the goal. To help you guys learn and grow and support you in your homeschooling, if that's what you need, or maybe you need it just for extracurricular learning. I don't know, but either way, it's awesome that you're here. All right, that is it. I will see you guys in the next video. Thank you for watching, and peace out for now.